So, yeah, basically wanted to start the conversation about this. I think we had some discussions as a part of Signode and even in the working group, like before the 135 cycle. But since we have time before 136, like wanted to see how we can start making some incremental like progress around this. So, yeah, like basically the thing that this cap is trying to solve is like with uh like native resources, we need a way in the scheduler and even within the node to manage like the same underlying resource being requested across like the pod spec and also now through like the DRA. I let me I we had some discussions on this, like as a part of this like draft kept that I've been like working on. So to give some context, like currently how we try to address this, or like rather have a workaround for this problem is like anytime like we have a request made through the resource claim, we also like duplicate the request in the pod spec so that the rest of the system, like the cube scheduler, the accounting part on the cube scheduler, and also like the kubelet knows like there is something external to it that is managing this underlying resource. So this is not enforced by like the DRA driver itself, but it rather like relies on the user doing the right thing and configuring things properly. This is obviously like very fragile, and basically the other like disadvantage is like with more advanced use cases like prioritized lists and so on, like it's harder, or it's not possible to know like when we create the pod as to what exact like request on the claim would go through things. Like I have one example that I've listed here is like if we have a resource claim which says like give me 8 performance cores or like 16 efficiency cores, or like give me 20 CPUs or like 1 GPU. So it's not possible to like set the pod spec like correctly based on this. So yeah, this use case would break. So at a high level, like the larger issue that we need to address here is like we have two accounting mechanisms like now within the cube scheduler. Like one for DRA, we have the dynamic resources plugin, and for like the rest of the resources we have like node resource, or node, I think it's node resources fit, yeah, node resources fit plugin, which manages like the rest of the resources. uh, we need something to basically tie like these two plugins, and also during the bind stage in the scheduler, like this is where we actually look at like all of the pods, and like the scheduler maintains like an internal cache called node info, where it maintains like what is the amount of resources requested versus allocated. We need like these two plugins to work with the binding mechanism to make sure every all of these have like a consistent view of like what resources are available. So this is on the scheduler side. On the kubelet side, like we rely on the native resources within the pod spec for a lot of things. Like basically we set the QoS class, which internally or which directly affects like how C group is managed, and how eviction and preemption and scores and things like that. So basically QoS class has a lot of like downstream mechanisms like within the node. So yeah, like now again, the like if we do not specify in the pod spec and like move to DRA, these are like some of the things that might end up like being affected. So yeah, this is the context. So the proposal that like we had like was basically some changes on the DRA API to make the scheduler work. But before that, like the a couple of like more high level questions which I wanted to like bring up here was like one, now with DRA, like basically do we say that like if DRA, if a request is specified through DRA, what how do we treat the request which is also specified through pod spec? So we can have like multiple accounting models here. Like basically we can say that like if a pod specifies both DRA and standard resource, DRA gets precedence. Or the other accounting models could be like we take some of both the resources, or like different accounting models based on the configuration. So yeah, like that is one part. And on the kubelet side, uh like one open question that I have is like basically, should or DRA based requests like start affecting like how QoS class is like determined on kubelet? And like if we do it, there would be a lot of like downstream effects of this. So yeah, these are the couple of like high level questions. Like we can also go into more API uh like details, but yeah, like basically in uh, yeah, Kevin.
Yeah, I'm curious. So it feels to me. So one question. One thing that you didn't mention. One alternative is that if you have a resource claim referencing a native resource,
Hmm.
it would be an error to specify a native resource in the the normal requests and limits section.
Hmm.
Uh, I'm not sure if that's possible, just because we don't necessarily know what the resource claim looks like at the time that the pod's being instantiated. But
Hmm.
to me, if we could make that guarantee somehow, that would
Hmm.
be the cleanest solution to me, right? Because imagine you could error out knowing that someone's requesting CPUs via DRA, and you
Hmm.
don't want to allow that in requests and limits. If that's the assumption, then all the other stuff that you talked about kind of goes away in some sense, right? You wouldn't have to worry about QoS classes, because that's only a concept that's relevant when you have, limits and requests set in your pod spec. And we just decide that that's not something that we're going to have be affected by the DRA style request. Um, Now, maybe this is just a thought exercise because we can't actually do this. But to me, it feels like it would simplify a lot if you could really have an either or, rather than trying to figure out, does one take precedence over the other, or does, this, that, or the other thing. John, I see you have your hand up.
Yeah. I mean, I think that's an option that we should investigate. I don't know that we can determine it at admission time, but we can determine it at scheduling time, and whether that's good enough or not. The thing is, we need to look at what some of the use cases are. So, like, so we've talked about use cases where you want to, like, the additive one. The additive one would be like, okay, I have a container that's kind of a control mechanism, and I want to give it a little bit of CPU and memory, and then I've got a container that's my actual compute heavy workload, and I want to give that a GPU, but if one's not available, I want to give it 20 pinned CPUs. And so I guess we could do that all in resource claims with two different requests for CPU and memory, one for the control container and one for the prioritized list of GPU. And so that would work. Like, we should think through what the use cases are. And I think we had a bunch of, I think Praveen has another doc. I don't know if he shared it yet or it's ready to share, but there he lays out like open questions, and some of the different alternatives. Oh, okay. And so like this kind of, we should enumerate, make sure that selection is on there. I know Sasha had a few different, we talked about a few different alternative ways to interpret those APIs. And we can just go through the use cases and pros and cons and see which ones make sense. But yeah.
Praveen, can you share the doc that you have? Because I thought the one I posted was the right one, and it's not. And I can't find the correct.
I just added that. So I think we did have like some discussions around that. Like basically, the existing draft of the KEP is kind of based on this idea that like if a user specifies in both the places, the DRA one takes precedence. I don't know if Sasha is here. Like he brought up a bunch of use cases where that might not necessarily work. Like for different use cases, we may want to specify at both the places. So in this doc, I have kind of listed like a couple of options. We may even say that like for alpha of this KEP, like let's start with you can always have like one thing mentioned in the pod, but and later like evolve into supporting different cases, but the API itself kind of needs to handle all of these cases, I think.
And I guess it just feels like a lot of magic if one takes precedence over the other. It feels unnatural to me.
Taking precedence feels unnatural, but additive doesn't. And like, there's different. I think we need
additive doesn't necessarily.
Yeah. Sasha's got his hand up. Yeah.
Yeah, but I think what we discussed with John and Praveen in private conversations, and I think it was also mentioned in this document what was shared here. So we have practically 4 different scenarios how we can do accounting for both if the values are specified in both places. So like one is sum of pod plus whatever is inherited from DRA claim. Second is let's say like pod is specifying for QoS class determination, but we can really ignore the value. So we just take what is the maximum, what came from the claim or what can come from the pod. And then there are scenarios when we want to have scenario accelerator. If you allocate that accelerator, add some additional like memory and CPU time to get it to the container. So that variant. When there is another variant when claim is pretty much like give me exclusive CPUs and I'm going to use those only. So we can completely ignore what was specified in the pod spec. When potentially another variant of accounting is when the same claim is used between multiple containers or between multiple pods, like how we calculate those in the scenarios. So what we discussed with John is the idea of having in the claim like the field which will be specifying like how we actually calculating those. And based on that, we will have like in all the places we are calculating what is the actual total amount of resources what will be given to the pod or container.
Yeah, I mean, the one option is sort of all of the above, where you have a field or a config option or something that lets you in the workload specify how you want the accounting to be done. And by default, we pick something we think is most common so people don't have to set it. So that's also an option. Yeah, Marlo.
I'd be really jumpy about a max, like take the max, because when you have resources that don't align in the same spec, you have unintended consequences. So the other cases, yes, but that particular one, I'd like us to just error out.
And one thing Sasha mentioned
that's useful actually in some of the workloads.
Yeah.
I mean, having a max is useful combination, so it's not an error situation.
If you have 2 things defined in the same thing,
it's not the same thing. Here's the
in the same spec, in the same file, and you have a max defined that's different than the max that you would expect from elsewhere in the spec.
So we are trying to support the use cases, not only just like let's drop everything from native resources. We are trying to make sure what we have a device in DRA scope which requires native resources. So in that scenario, like Max might have the need.
So one of the scenarios that, sorry, Jack, one sec, that we kind of, Sasha kind of mentioned in passing, this is, I would almost consider this maybe a separate KEP, but we need to think about it, is when you share, so there's different parts of the claim lifecycle, and at least Sasha has expressed use cases where during some of those cycles, you might allocate additional resources. So for example, each time you share the device, whether that's a GPU or a compute device of some sort, there may be additional overhead associated with that, so that like there's some allocation done. Like one of the things Sasha mentioned, and that isn't necessarily what exactly what we're talking about in this KEP. So maybe it's like I said, the separate KEP is, oh, if I'm allocating a device, maybe there's some overhead associated with it that's native resources. So should I be able to attach to any device the native resources that are consumed in addition to the device being consumed when that device is allocated? That's different than I want to explicitly allocate some CPU. This is like, as a side effect, when I allocate this GPU, I need a gig of memory to manage something in the main system memory.
But John, in my description, those two scenarios are exactly the same. The just name of a device will be the CPU. So, like,
right,
the DRA driver announces the CPU as device.
Because there's a separate field. So Praveen and I were talking about this yesterday. There's a separate field called the count of devices, and if we take that, it becomes super confusing. Is it like per count? Is it per? So like, I really think we're going to need to like write down these APIs, write down the operations, write down the life cycle events that happen, which include allocation, sharing between containers in the same pod, sharing between containers in different pods. Some devices can be like network interfaces are pod level, whereas most of them are container level. What are these? Like, I think there's so many, like, we have to enumerate all of these questions, and we have to come up with the API and reasonable answers for all of them so people's heads don't explode. Like, so that's kind of where I am, and that's what I was trying to raise. There's more than just like, so this KEP, what I suggest we do is like, let's try to focus on what incremental progress we can make on this path in 136. And as opposed to trying to solve all of these problems in 136, but let's at least enumerate all of them and start the discussions on all of them and see if we can make a little bit of nudge of a progress in 136. So that's kind of where in my mind, the target of this whole conversation is like, let's try to make sure we're elucidating all of the issues and then make progress towards where we're going. Jack, unless Sasha has a response to that, I think we can go to Jack.
Hey, go ahead, Sasha, if you have a response.
No, Jack, go ahead.
Okay, cool. Yeah, I just wanted to clarify that the main sort of net new problem we're trying to solve is that we're hoisting native resources into the DRA spec as a part of the standard DRA API. And if we're talking about, as a result of that, what do we do about inputs that will use this new API but also continue to use the old API? Is there a canonical use case where we actually wouldn't solve by hoisting all the native resource interfaces into DRA themselves? Haven't we solved for all the native resource use cases by doing that? We just then require folks, if they're going to use DRA.
That was Kevin's point.
Well,
like let's just not put it in the container spec anymore.
Like, I'm not saying we need back compat, obviously. We're not
address
going to force users to use DRA maybe for a while, right. but if we move everything into DRA, why would we? What is the justification for ever allowing users to specify both?
Can I address this, John?
Sure.
So if you're using a daemon set where you really don't care the type of native resource that you have, you should be able to ask for just a native resource. So we'd end up asking for users to now do a definition that maybe doesn't make sense for them because it's more.
Well,
that's a different thing that I'm describing.
Like we would still allow that for backwards compatibility, but like it's sort of like once you start using DRA for it, then on that pod you got to go all the way. I mean,
yeah, that's what I was trying to say.
option
Yeah.
we need to evaluate. I think it's a viable
And that
option.
seems to me like, honestly, that seems like an admission problem. Like we should be able to successfully.
Problem is we can't do it at admission. That's the reason I
No, okay,
just
fine. Okay, I
hesitate to
understand all
even
those
bring it
reasons.
up.
Okay, fine.
Yeah, admission, because we don't, because they're separate objects.
Yeah, no, I get it.
And I would add to it. So like we cannot just simply drop whatever is present in the like as a native resources, because like there are like millions of workloads existing in the ecosystem and millions of tools which is also consuming them. So like backward compatibility is one thing. Second thing is the performance. So like processing DRA claims, even if it's specified in the pod spec, it requires additional calculations. So we don't want to force users to do it. Another thing is what like you can have a simple cluster which doesn't have like DRA driver which will be representing native resources. So you should still be able to deploy the workloads and have it intercompatible. So like I see the whole this exercise what we are having here is scenarios when just description of like give me free CPUs is not enough. So it's the whole exercise of when give me free CPUs with particular property, or give me memory with particular property, or combination of that, or combination with devices. So in that scenario, like DRA usage and DRA scheduling overhead is justified. For standard workloads, why do we want to spend additional compute cycles to?
I think we're all agreed there, Sasha. I think we're all agreed there. Praveen?
Yeah, one question I had about like providing different allocation modes, like basically sum or like replacement or whatever we decide. Would that be like a configuration option on the claim? Like we need a new API on the claim to kind of enumerate what all
Yeah,
of these
I wouldn't
options?
want to put it on, like it should not be a cluster administrator thing. It should be, because then different clusters will behave differently in an unpredictable way, and that will be disastrous. It should be something the user has control over, if we have it at all, right?
Okay.
So now there is a question if we have it at all, because it adds a lot of complexity. So maybe we can not, which would be good. But like let's enumerate what that would mean. Yeah.
Well, we need to enumerate and we need to start implementing those, because like if we just like simply blind our eyes with just like few small use cases, we will get the problems down the road.
Yeah.
So
yeah, back in the
let's not repeat our previous mistakes.
Yeah, back in the early DRA, well, in the reboot of the DRA, the structured parameter stuff, we put together a list of like 50 or 60 very concrete, like, I want 2 GPUs. I want 2 GPUs in the CPU. I want a GPU and a NIC, just like dum 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 dum. We probably want.
Where is that? I remember that, but where is that list?
I can find that pretty quickly.
If where you're going is where I think, John, huge +1. Let's get that use case for that set of use cases for this as well. That would be hugely useful.
Yeah.
I'll find it, and we can keep the conversation going, and I'll look for it while we do that.
Yeah, so this was like on the scheduler side, like I think like based on once we enumerate all the use cases, like I've also listed a couple of options with like the API, but it feels like we need to first enumerate the use cases before we can kind of start discussing more on the API side. So I can take that as a follow-up thing. Like, and like the other question I had was on the node side, right? Like so like now we implicitly kind of assign QoS classes, as I was mentioning earlier. Like do we start looking at like native resources as well during this implicit like assignment of QoS? And or like the other option that I've listed here is like basically continue using like native resources for QoS. Like should we is there a transition path from like using just native to native plus DRA? Like that is something that I wanted to bring up. Like for alpha, like what do we target like on the node side?
Well, my opinion, what I wrote in the doc is what we need to continue using the QoS calculation based on the native resources, just not to break anything like in the ecosystem. If you want to change that, I would rather go directly to the explicit QoS class declaration field in the pod spec, because that will solve a lot more of our problems.
I saw your comment. It makes sense to me. We don't want like, I guess today all the tools already calculate it based on the current rules, and we don't want all those tools to have to change their rules. I mean, I guess if you went to explicit, then they would have to read the explicit one, but
Small comment. So Francesca pointed what the function which calculates the QoS class is actually exported one. So like some of the tools who are directly consuming the Kubernetes code from the Go, they are safe. Most probably they will be just needed to be upgraded. But we don't know like what kind of other languages or other libraries people are using. Yeah. So for example, like Carpenter, it's written in Python. Well, some pieces of it. And,
right. So one question I have is for 136 time frame, and I know it's early to we're not, we haven't finished 135 yet, but this is like, do we focus on the API, and is there any use case that would be totally broken that we have to do something in the kubelet to address now? Or do we try and figure out the APIs and the use, get better clarity on the use cases, get better clarity on all of these pieces before we start touching kubelet and all the consequences of that? Marlo?
I'd like to be really, really clear on the APIs sooner than later, partially so that different hardware vendors like Intel or AMD can put together their own underlying driver if they want to. That's particular performance metrics. So to me, that's kind of the most important piece. The rest of it is kind of less important.
Okay.
Yeah, and does that imply? Sorry, Sasha. Does that imply, for now, meaning that however many CPUs you request with the DRA driver, you still have to manually put that number of CPUs in the native request?
No, that's what we're saying. We would focus
no.
as opposed to the kubelet side work, right? Like we only have limited resources, so we can't necessarily like do both scheduler side and kubelet side, and like so. And maybe if we screw up the API, right? This is alpha, and we decide to completely change it, and we've made kubelet changes, and then we have to, it might be just more work. So, what I'm wondering about is today we have workarounds like Praveen has, right? There's basically the DRA driver consists of like, a DRA API driver API and an NRI plugin API, and he's able to do most of the stuff we need. And there's some issues where like, we had talked about needing coordination between the driver and kubelet. Like, I don't know that we want to go there yet, right? This is kind of what I think.
Yeah, today, like, I think kubelet still sets up all of the C group hierarchy and everything. And it's also responsible for like setting, I mean, specifically with CPU, we might have like similar things for memory as well, but it sets up C group hierarchy, it sets up like CPU shares and quota, and then the DRA driver takes over and like sets only the CPU set. So one concern with like not doing the node part for now is like kubelet would categorize this pod like, I mean, even though we are requesting guaranteed resources through DRA, it would categorize it as like a best effort pod. So basically, if there is some like a contention on the node for like resources, this would be one of the first pods to be like evicted. The other one, like the CPU shares and quota, we might still have like some workaround like that we can do on the NRI plugin side to set these things correctly. But yeah, like we would still have some like drawbacks for not doing the node side.
QoS class categorization is a big one. Yeah, but Sasha and then Francesca.
So to answer our original question, what we need to focus first, I would suggest let's focus on the claim syntaxes and APIs and what, like how we explore, like how we can specify what is the native resources consumed by the device, because there are like a lot of, well, there are nuances where how we do it. Second thing, what we need to think is about like these accounting mechanisms, because like it's not a problem to adjust whatever is passed to runtime. We can adjust it easily, but we need to make sure what the kubelet will be calculating, or scheduler will be calculating capacities of a node correctly. For QoS class, I would suggest let's not touch, like let's use whatever is currently present. And the main reason for that is actually to fix the big design disaster what was in CPU manager, which ties the exclusive allocation to the guaranteed QoS class. You can have absolutely easy like the burstable container, which can have like several pools of CPUs allocated. Some exclusive, some is shared. So we shouldn't be tying too much like how the claimed resource behave versus what is the pod QoS. Pod QoS is mostly like for priorities, for eviction, and so on. So like main API, accounting, like drafting how a scheduler works, I think that's the main point.
Hey,
Francesca?
yes. So I agree, or at very least don't disagree with everything what was told before. And the point I want to make is that we are at very least having two main issues, well, not issues, two main things right now in front of us. One is what we can express with the API, and the second is what we can do with the, with the API we are given. So from the node perspective, if we don't do anything else in the kubelet, even add knobs to say, okay, I'm not touching it anymore, and the agency, what a DRA driver can actually do becomes quite limited, to the point that, okay, we don't have the tools to express that, but at the same time, we don't have also the opportunity to change, because kubelet is owning basically this group layout, and it has its own reconcile loop, which in some cases you can disable, the CPU manager one, in some cases you cannot, the node and QoS managers. So those two things possibly may go in parallel. This is the open question I have. But surely the point I want to make is that sooner or later we'll need to have kubelet stop doing what it does and allow other drivers to, or their entities to do something more.
Yeah, I think I understand you. Yeah, you have a lot of ideas here, and so from that sort of like go parallel thing, I mean, I think that'd be awesome if you have the bandwidth to make progress on the node side. I just know Praveen and I, and we don't have the bandwidth to do all that. So from our point of view, that's what we want to kind of focus on, is the API side. But like, it would be great if we can make some progress on the other side. It's just we got to make sure that if we screw up the API and need a couple more alphas to get it right, we don't mess up the that doesn't have impact on what you're doing there. But
yeah, so like we see group hierarchy management right now is not critical. It's really nice to have. It's really good if it will be in the CRI protocol, but it's not urgent right now.
Okay, less work, fine.
So yeah, that's everything I had on the note side. Like we spoke about like the cube scheduler. I think these are like mostly implementation like level changes that we'll need. Resource model, we did speak about that. API, I think like I'll spend some more time on enumerating all the use cases before having like a more detailed discussion on the API itself. Maybe like we can iterate on the
Yeah, and we
I
should crowdsource that, Praveen, because like you're obviously you're not going to like. So I did put in a reference to that other document. If you can create a document similar to that for the CPU use cases and the joint CPU, you know, other device use cases, just try to keep it brief, like those table entries, so that we can just see a long list, even if it's not perfectly accurate.
Okay.
And then like other folks can go in and just add a bunch of stuff in there, and hopefully we'll get enough material to evaluate APIs against.
Yeah, makes sense. I can do that. I can sync up with Sasha on like the use cases that he is thinking about, and yeah, come up with that doc.
Just to say it to this big group of people who are currently here. So the whole reason why I'm driving for like a lot more than just like simple, let's allocate a couple of CPUs, is because we are going to model different devices or improve usability of different devices. Like one big device, what I have in mind is CXL memory. So it's something what can be dynamically attached to the node, and well, when it can be used to a workload. And for that, it has some chunk size. So we think what is currently implemented for consumable capacity, like it helps me because like I can declare in which chunks I can allocate and attach for memory, but that also means what I need to have, like not just like simple memory, I want 1 gigabyte. I want to have a more flexible way how it can be. And the second property of CXL memory, what it potentially it can be a buffer which is shared between multiple hosts. So like I need to have a properties about how it can be consumed for different workloads. So that's like one scenario. And another scenario is what also mentioned, like improving the usability of devices. It was briefly mentioned by John, but just to talk about it loud. So like every time when you allocate the device, you might have different resource requirements about how you're interacting with that device. Like you can allocate, let's say, like 0.5 CPU core just to interact between like host and device. You can have like gigabytes of buffer, or like specifically like huge pages needs to be allocated. Right now, the usability of all of those is quite broken. We need to express the user saying like, well, whatever you have for your workload, please add a couple of more things. So with DRA, I'm hoping what we can improve that functionality, saying what like, if you allocate, let's say, like Intel FPGA, you will get a huge pages as well. So something like that. So it's not only about like just pure native resources, as we know about one. It's also about how it will be in the future devices.
Right, Marlo, do you mind if I respond to that, or unless you're?
Yeah, go ahead and respond. I have a separate item.
So I think that those are super interesting use cases that need to be enumerated. I think that, like on your comment, you talked about adding that in the device class. I'm not sure that's the right place to do. So there's a few different things you mentioned, right? Like one is an attachment flow, like, and you need to think about what that attachment flow looks like, and what the APIs are for the vendor versus the cluster administrator versus the user to control that attachment flow. Like, so this is where there's like really thorny, like tricky little things in there. Like, it's like when we look at those so that's another lifecycle element, right? Like, is the attachment of the device to the node. And so at some point, like, yes, you could have an API that specifies chunk sizes and things like that during that attachment process. I think that's a different API than the device class, and I think that's a maybe even a different API than, well, it's definitely a different API than the consumable capacity, which is a user-facing thing. So it's probably an API on the resource slice. So like there's like probably four.
John, you misunderstood me. I can clarify it, but to you directly what I meant. You misunderstood. I didn't mention it the class part.
Okay.
So it's property of a device, how we announce the
Okay.
exact device.
Okay. Yeah. Right. So property of a device, but that means it's only in control of the vendor, right? So the vendor is saying, always, this is how it works, right? And so like, we just have to understand and prioritize all the use cases and the APIs. So yeah. It's a lot.
Are we also going to align by NUMA node? I'm joking.
Well, for that we already have mechanism.
Can you?
Yeah.
Can you at runtime change the configuration of the noontime in the kernel without a reboot? Because that would be really cool. So we could like. I'm again joking. Okay. Marlo.
I would like, we don't have this in here and we don't have to solve this today, but we've discussed briefly about how what a user may want to expose may be different than the granularity needed by a scheduler.
Yes.
Yeah, with the specifically, the specific core enumeration, because that will matter to schedulers with an HPC or with telco, but a user isn't going to want to enumerate which cores. Hi, Kevin.
Hi, Kevin. Yeah. So just to fill everybody else in case I don't know where this has been discussed, what Marlo's talking about is the idea that like look at the CPU driver right now. We're sort of it can be operated in two modes. It can be operated in a mode that explicitly lists each core as its own device, which is extremely verbose, but gives the maximum control to an external scheduler like Slurm, which can go in and be like, I'm assigning this core, this core, this core to this container, this core, this core, this core to that container, and that's what it's already got the algorithms to do that and can make those decisions optimally. And then there's another mode you can run it in where you say, okay, each socket is a device, and then that all the cores in that socket are a consumable capacity value on that, and that's a little more allows us to do a lot of the alignment cases by socket or whatever, but like isn't so verbose. And so Marlo was wondering if there's a place like right now we have one API, which is the resource claim API, and both the external scheduler and the user use it. And like, is there an opportunity for something in the middle, which can take the user rougher intent and have the scheduler enhance it? I mean, I think that's what you're going to do now. It's just, I'm not sure if that's done through a scheduling gate or what now, right? Like, so like, what is the process for that? And again, it's probably not, I think this is made more visible by this problem, by this native resources. I don't know that it's not exclusive to the native resources, but I think it is something we should be thinking about.
But John, what we are talking about is like different like vendor drivers who represent the resources differently. So
yes, and that would be absolute. That's kind of the plan. Like SchedMD can have their own driver or a variant of this driver or whatever that enumerates them all. Because the ordinary part of my concern is when you've got 128 devices or whatever. I see in the chat, because that's max devices. That's in a single slice. But now we fixed we can have as many devices as we want in a pool now, and they can. Morton's done a bunch of fixes to make certain things operate across those slices. So it's not such a problem as far as the API server limits now, but it is a problem from the scalability of the DRA algorithm, which is extremely naive. It's very like, it's a depth first fit search of a possibility tree, and it's like it can explode in its time complexity. Like to million to, I think Morton did it and Praveen did a calculation, and it was like, you know, oh, we could spend like 10 million years calculating this one thing, right? Easily. So like, obviously that doesn't work. The thing is, like, when you're running Slurm, we're not going to use that algorithm because Slurm's going to go and say, no, you're not going to do the depth first search. Instead, I'm going to tell you this core, this core, this core, this core. And so our scheduling process, and I need to confirm this is true, but I'm pretty sure the first thing it does is it makes a pass through and says what devices meet the selectors, and that would go down to 1, right? Because only one device has that core ID, and so then you don't have to try all the possibilities in that enormous tree to meet some constraint. So like,
but John,
Yeah.
a consumable capacity with limited set of attributes is exactly for that. So when the DRA driver gets the prepare the claim, you can get these properties, and when you can select, you don't really need to expose those actual IDs to the users. So it's all possible. It's like Christian had
my point, and maybe I went on too long. My point was like there's different like in the case where you're using something like Slurm, you may want, we want to expose a lot of detail on the drivers, but if users use that level of detail and then try to use the ordinary upstream DRA allocation algorithm, they could get themselves into trouble, right? So like people need to pick like which mode they're running in based on whether they're running upstream, purely upstream scheduler, or they're running another scheduler, and I don't know how to protect people well in those situations.
We need another interface. Yeah, we need another interface in the middle. Sorry, go ahead.
We cannot really protect the people because it's similar to, like, let's say, like GPU drivers. Like Google has its own implementation, NVIDIA has its own implementation, or like some other cloud provider also have modified NVIDIA drivers. So like in theory, they work similarly, but it's your cluster configuration, how you want it to have it. And with DRA, we have a nice way we can declare a class. So we cannot, or we wouldn't end up in the situation when the user is asking for a particular class of native resources driver, and it will end up by served by something else. So like upstream driver will have one class, Slurm will have another one, vendor like Intel, AMD, we will have our own class names.
But then that raises the question of, in general, we've disallowed multiple drivers to manage the same resources and on the same node, right? And so we have to, But anyway, Swati's been waiting extremely patiently over here.
Yes. Thank you. I have kind of a fundamental question which is related to resource representation. I think we've established that we want to represent, say CPUs through the DRA API. My understanding so far was that now that we've kind of made things work past environment variables and, using CPU set to perhaps, indicate that CPUs are exclusively allocated with the help of DRA API. What I was essentially wondering was, do we want to have a clear indicative way of capturing in the API that now DRA handles devices as well as native resources? I think my question is, I know we are modeling CPUs as devices, but I was wondering, like, do we want to actually separate that out and capture clearly that, we have devices and we have native resources, both managed by DRA? And, as an example, like we are currently hacking our way using, say, the CDI API, which was explicitly designed for, devices, but now say like using environment variables through container edits and things like that. So I think what I'm trying to say is, we have established a pattern here. How do we make it more explicit from API perspective? And what I'm worried about is, once this mechanism of using this API and this pattern happens once, it's going to be hard to go back.
Yeah, I can try to respond. So I think like the intention is to make this like more explicit. I have listed one option. I mean, there are some still like discussions that are like ongoing on the doc, and it might turn out to be like something completely different from what's mentioned now. But yeah, like the intention is to have a way for like in the device class have some way to specifically call out that this is not like a device, it also represents like something more native. uh yeah, I don't know, does that
Yeah.
answer your
Yeah,
question?
I think that makes sense. But I think what I'm saying is even kind of at a lower level, say, how we pass CPU set information through the NRI, we probably need an explicit way to capture, this is CPU specific information being passed down to the runtime, rather than using kind of the like I'm okay for us to use CDI, but even just having thoughts about, do we need a separate API implementation or a different layer or a separate field just for native resources, I think would be useful for us to kind of have a conversation in the KEP itself.
You're talking about on the on the node side, like in the
Correct.
CI or the CRI or somewhere.
That's right. Yeah.
Okay. Yeah, I think that's. I mean, I don't know if it's this KEP or a different KEP, but like it's definitely a conversation we should have 100%. Yeah.
My short answer to that. So CDI and the way how we can pass the information right now is enough for us to do the minimal things. If you want to extend that, it means like it will be like extending DRA node APIs, and then we need to push everything to CRI API, and so on and so forth. And that will be like huge release cycles to all the components. We don't really want to do it. So like we might come to that scenario what like something needs to be enhanced between the DRA driver and kubelet, between the kubelet and runtime, but probably not. It's not urgent in my opinion right now.
Sasha, I think I agree with you that we don't need to make changes to CDI per se, but what I think we can think about is perhaps adding a field in CDI itself to explicitly say that this information is related to native resources, as opposed to saying that this is a device model as CPU model as a device, and we are passing like the CPU set information under environment variables. I think that's what puts me off with the current implementation right now.
Yeah, so putting my CDI maintainer hat on. So the problem is what we don't have a clean syntax to specify in container edits. Like if you want to modify some of the parameters inside the CDI. So like in case of like environment variable, mount points, or device nodes, we have a flexibility. What like it's usually you are either adding or you are removing or overriding whatever kubelet is passing, or whatever is runtime created in OCI spec by default. But if we want to say like increase like with CPU shares quota by number something, we simply don't have good syntax for doing that. It was there were also some requests in the past about enhancing the CDI spec, but we haven't found any good solutions. That's why I'm saying like not urgent right now, because anyway you need like you are using NRI hook, and where you can have a lot more flexibility of how you do it. So CDI, in a sense, passing only just like handle, like whatever you've seen, whatever is allocated, here's the handle, here's the information, and then you can use the information what you got from the kubelet, from the claim, or during the prepare resource.
Okay, we're almost out of time. Marlo and Christian, and then we better wrap it up.
I was just going to note that we're about out of time, and we should probably come up with a schedule going forward. If this time works for people, maybe we should stick with it every week until we have a progress.
I mean, it's sure. I think that we can. You want to set up a standing meeting? You're saying to continue on this.
Yeah, this is bigger than just one meeting. This was the kickoff to start discussion, but.
Yeah, usually I mean, that's fine. Absolutely. We'll do it. We'll do the async stuff over the KEP and the docs, but I'll set up a a meeting, and I'll use the Zoom one, and I can give you, Marlo and Praveen, the host key so that you can, if I'm not there, you can still run the meeting. Christian?
So just a small comment to Swati about this environment variable hack. So that was only put in place because over the NRI interface, it was not possible to pass to a plugin which CDI devices were injected by name. But this has been fixed ever since. So now basically what the NRI part of the DRA driver can do, it can just retrieve the names of the devices. So the CPU devices it has injected, and then it can directly load the spec and look at, for instance, it has annotations. So I mean CDI spec annotations, and it can convey information to itself via those. And so I think this environment variable hack is not necessary anymore. So it was an ugly hack which we put in place because there were not other mechanisms were missing there, but those, I think those holes we have plugged.
Thank you, Christian. Appreciate the explanation.
Dawn?
I just have one last thing, just try to echo what Manuel earlier mentioned, because I think the API, and at least for me, maybe it's just me, and unclear how we plug in the external scheduling clearly. So that's part of the API things. I think we didn't put enough thoughts on that one. The whole thing, original, we're using this as example, it is just using Snurm workload as example. Right now, I only see moving forward on the node side, I couldn't see how we are plugging in Snurm scheduling to help that and clear, yeah. I don't know how in the 1.36 timeframe we can make that progress, or at least hopefully we can move one step forward on that one.
Okay, let's start thinking about that and how see if we can clarify the flow there and make sure that see if there's something more we can do to simplify it. Awesome. Okay, well, thank you, everybody. I think I'm like a month behind on posting recordings, but I'll try to post this recording, and I'll put a link to the Gemini notes and stuff too. So thanks all. Bye-bye.
Thanks everyone.
Right.